Solving equations of the form a times x equals b. To solve the equation a times x equals b, where a and b are numbers and x is an unknown, our goal is to get x by itself. We want to obtain the basic equation x equals a number. To get x by itself, divide by a on both sides. So we're just talking about equations in this form right now, and our goal is always to get x by itself. We say x, but we mean a variable. It could be a different letter like y, or z, or alpha, or beta. But our goal is to get x by itself. And the operation that's being performed to x by the number in front is multiplication. See, it's a times x. So think in terms of doing the opposite. What's the opposite of multiplication? You can think of it as division. Same thing if it was an addition problem. If it was adding a number to x, then we would subtract a number. If it was subtracting a number to x, then we would add a number. So think in terms of opposite when you're solving equations. Okay, in this section of solving equations, this will be very useful when we get to solving proportions. So even though it seems like it's an algebra section, it's really an arithmetic section. We still have to use a little bit of algebra in an arithmetic class. Okay. 2 times x equals 22. One way we think of division, or one way we use fractions, is for division. A fraction, as we learned previously, is used as a division problem. So what we're going to do is draw a line under each side to indicate division. And then 2, write the value of a below each line and simplify each side. So what number is in front of the x? 2. So put a 2 under each line. Okay, now we're going to simplify. Now what's 2 divided by 2? Well, anytime you have the same number over itself, it's equal to 1. And then 22 divided by 2, that's equal to 11. So we have 1 times x equals 11. And then 1 times x is x. So that's it. Now I know some of you might be thinking, I could do that in my head. I don't need to show those steps. Probably many of you can. But this is not a complicated equation. Equations are going to get more complicated in the future. If you learn the proper procedures and steps now, when it's easier, it's going to make it easier for you to solve the more complicated equations of the future. So we're trying to just learn the proper process. I promise you this will make it easier in the future. Okay. So again, develop good habits now and it pays off later. Let's do another problem. 7 times x equals 63. Draw a line under each side to indicate division. So draw the line. And then what number goes below the line? That's right, 7. So write the value of a below each line and simplify each side. Now 7 divided by 7 is 1, so 1 times x is 9, and x equals 9. Okay, here's another one. Again, draw a line underneath each side. And then what number is going to go below each line? That's right, 5. Now, you don't have to write it as a 1. 5 over 5, what is 5 over 5 equal to? Yeah, it's 1. Or you can just line them out Many people prefer to do it that way. So just bring down the x, and then 45 divided by 5 is 9. Okay, let's move on. Answers are not always whole numbers. They could be fractions or mixed numbers. Okay, so the previous problems we worked out, the answers came out to be nice whole numbers. But this time you could get fractions or mixed numbers. So let's work those out. Again, what's the first thing we're going to do? Divide by 5. So the 5's cancel. And then 5 into 37 does not go evenly. So we're going to need to divide. See, 5 goes into 37 how many times? 7. 5 times 7, 35. Subtract, you get 2. So the answer to this one would be 7, and the remainder over the divisor, 7 and 2/5. Okay, you might want to pause the video and work on the next problem. Just be careful with the next one because there is some reducing that you could also do. I like to do the reducing at the end, but it doesn't matter actually. Okay, divide by 12 on each side. 12's cancel, so now we're going to divide 12 into 40. If you chose to divide both of those by 4 right now, that's okay also. I'm just going to go ahead and divide 12 into 40. 12 goes into 40 3 times. So I got 3 and 4 12ths. Oh, can we reduce that? Yes, by 4. So divide both by 4, and that gives you 3 and 1/3. If you would have divided by 4 first, that would have given you 10 over 3. And then when you divided 3 into 10, that still would have given you 3 and 1/3. Either way, it's okay. Either divide first, then reduce, or reduce, then divide. Alright, let's move on. Here's 2 more problems. They come out to be fractions as well. Okay, the first one, divide by 18 on both sides. Remember, the number you put below the line is always a number that's before the x. 18's cancel. Now that is not an improper fraction. It's a proper fraction. It just needs to be reduced. Okay, so we remember to change an improper fraction to a mixed number, we always divide the bottom number into the top. At no time do we ever divide the top number into the bottom number, the numerator into the denominator. Okay, so we can reduce it. What number goes into each number? That's right, 2. 2 goes into both of them. So that gives us 5/9. I want to pause and work up the next one. Okay, divide by 55 on both sides. 55's cancel. So you get 11 over 55, and then we can divide both of those by 11. Our answer is 1/5. Okay. Solve an equation of the form a times x equals b, where a and or b is a fraction. So either side, if either side has a fraction, this is our procedure. It's almost the same, it's just a little bit different the way we present it. Okay, what we're going to do is multiply both sides of the equation by the reciprocal of a. And then second, simplify each side. Okay, and I wrote another. This is really the same procedure. When you divide by a on both sides, remember dividing by a number, that's the same as multiplying by its reciprocal. So when we divide by a on both sides, this is equivalent to multiplying by the reciprocal of a on both sides. Okay, so here's our first problem. 2/3 times x equals 18. Well, what is the reciprocal of a? Remember, a is the number in front of the variable. So what is the reciprocal of 2/3? That's right, 3/2, 3 over 2. So you're going to rewrite the equation, but on both sides, you're going to put a 3 over 2 either in front of it or behind it. Excuse me. So a 3 over 2 in front of the 2/3, and a 3 over 2 next to the 18 over 1. You can either put it in front or behind. It doesn't matter because multiplication is commutative. Okay, keep in mind, whatever you do to one side, you have to do to the other side. Now, what happens on the left-hand side? Well, those all divide out, they cancel. So on the right-hand side, can we reduce? Yeah, the 2 and 18, right? 2 goes into 2 once, and 2 goes into 18 9 times. And now we can multiply across. That gives us 27 over 1, which is 27. Okay, so another problem. (18 over 35 times x equals 12 over 25). So we're going to rewrite the problem and multiply by the reciprocal of a on both sides. So the reciprocal of a is 18 over 35. Sorry, the reciprocal of 18 over 35 is 35 over 18. So we're going to multiply both sides by 35 over 18. Okay. Now, the numbers on the left-hand side divide out, and then on the right-hand side, we're going to simplify and multiply on the right-hand side. Okay, so the 35s and 18s, those cancel. And then on the right-hand side, the 12 and 18, they reduce by 6, and the 35 and 25 by 5. So 6 goes into 12 twice, 6 goes into 18 3 times. 25 and 35 by 5, 5 goes into 35 7, 5 goes into 25 5. Now we can multiply across, and that's our final answer, 14 over 15. Okay, let's do another problem. 6 times x equals 2 1/3. Okay, you might want to pause and work on this on your own. This will be our last problem of this lesson. Remember that anytime we're multiplying or dividing with mixed numbers, they have to be changed to improper fractions. Okay? And anytime we have a whole number, that's right, you have to put a 1 underneath it. And then what's your reciprocal of 6 over 1? That's right, 1 over 6. Okay, so we're going to multiply by the reciprocal of 6 over 1, which is 1 over 6. Nothing reduces this time on the right side. On the left side, the 6's cancel. So our answer is start 7 over 18. Okay, that was our last problem, and I'll see you here for the next one. Have a good day.